Hello everyone. In this video, we'll see how to write a Python program to find the determinant of a matrix. So I've taken a random 2 by 2 matrix here. So before getting into the code of this matrix, we'll just look at how do you compute minus. So I've taken a 3 by 3 matrix here whose entries are 1, 2, 3, 4, 5, 6, 7, 8, 9. Now if you want to compute the minor corresponding to this entry 1, then you are going to close that row, close that column, and of what is left you are going to take the determinant. So minor corresponding to the matrix A of the 0, 0th position. This will be what? It will be the determinant of 5, 6, 7, 8. Okay. If you want to compute the minor corresponding to this entry 6, then I am going to hide that row, that column. So that will give me minor of the matrix A 0 first, row 1, 0, 1, 2, column number 2, and that will be 1, 2, 7, 8, and I will take the determinant of that. Right? Now, in general, if you come to a n plus 1 cross n plus 1 matrix, and you want, let's say, the I comma jth minor of the matrix A, then how do you do that? So I will have to remove the ith row from this matrix. So ith row, this is 0th row, row number 1, row number I is here, this one, where I put a double arrow. So I will have to remove this entire row from my matrix. And the jth column, this is the 0th column, column number 1, column number j is here. I will have to remove this entire column from here. Okay. So to remove the ith row, it's easy because from this matrix you remove the ith entry in that list E. But to remove the jth column, from each row we are going to remove the jth entry. So that's how the column will be removed. Okay. So let's see how to get the minor function. So we'll have to define the function for the minor, right? So I will come back to my Python screen. Yes. So now what I'll do is I will define a function for the minor, right? So let's call out a function. Define minor, M-I-N, I'll call it. OR, you can put the full name if you wish to. Now, what all are the arguments that are required here? Firstly, I will need a matrix and I'll need the position, which minor I want to compute, right? So let's say I want to compute I comma jth minor. So I will have to put ith row position, that will come here, and jth column position, that will come here. Okay, so minor is the name of my function. A, I, and j are the respective arguments. Now, what we will do is we will create a dummy matrix. Okay, I will call it, let's say, capital K. Now, capital K will be what? I want to actually get the entries of the matrix A itself in this. So I'll take A for A in row. Okay, for A in row, and for row in J. So basically, what am I doing here? I am taking each entry from row, where row is each entry from, not J, from A. Right? So this matrix K is, it's like I have a matrix A and I want to perform some operation on A. So what I'll do, I'll create a clone matrix of A, another matrix which is exactly same as K, A, which is K, and those operations I will perform on K. So K matrix is exactly the A matrix that is given to me. So firstly, from this matrix K now, we are going to remove the ith row. Now, whenever you want to remove an entry from a list, okay, so you call out that list. The name of my list is K, capital K. So that is the name of my list. Dot pop, pop, and in round brackets, you give the position. I want to remove the ith row, so I'll give I. So what this command will do is pop I from the K matrix, it will remove the ith row. I hope it is clear. Now, for each row in K, I will have to remove the jth entry. Okay, so for each row, for row in K, this is a for loop actually. For I need not say row also, for R in K, capital K, what I have to do? R dot pop J. So what this will do is from each row, it is actually taking each row from the matrix K and removing the jth entry, the way I had shown it on my writing pad. Okay. So the first command K dot pop I removes the ith row, and then for each row in K, I am removing the jth entry. And after that, I'll tell Python to return the matrix K as. So at the end of this process, what I'll be having is the same matrix A which is there, but the ith and the jth uh, rows, ith row and the jth column removed from it. So that will be the corresponding minor Aij. Okay. And now we are ready to move for the determinant. So for determinant, again, I will have to define a function. But before that, on my writing pad, we'll quickly have a look how we are going to do that. Now let's look at that n plus 1 cross n plus 1 matrix. So if I want to find the determinant of that matrix, how do I go about it? I will have to, I can expand it along any row or any column. So I will expand it along row 1, row 0. So I will have to take A0, 0 and multiply, hide that row, that column, and take the determinant of the rest. So that is actually the minor of A corresponding to the 0, 0 position. Then I change the sign. This is normal determinant expansion. A0, 1 into the minor corresponding to the matrix A corresponding to the 0, 1 position. Right? So I'll keep doing this. And my last entry will be minus 1 raised to n, right? Minus 1 raised to n minor correspond of the matrix A corresponding to the 0 n position. So this is the determinant expansion that I have if I expand it along the 0th row, the one which I am highlighting right now. But this, if you see the pattern, this suffix 0 remains the same always. Okay, I have not multiplied A0n here, so that I have to multiply. That remains the same. Whereas this second suffix keeps changing. And same thing happens inside the minor. So this actually I can write it as sum of A0I multiplied by minor corresponding to the matrix A of the 0ith position, where I will take all the values from 0, 1, 2 up till n. So if you put I is equal to 0 in this, you will get this. Now I have to accommodate for this alternate plus and minus sign. So for that, I'll have minus 1 raised to n multiplied to this. So this will give me the entire determinant where I is running over the all the numbers from 0 till n. That will depend on the order of your matrix. So this expression is what we are going to code now. Okay, minus 1 raised to n into A0I into minor corresponding to the matrix A of the 0ith position. Okay, so you can pause this for a minute and have a look at it. By then, I will go to the Python screen and will define define the function for determinant. So now I'll define the function for determinant. So let me come to my Python file here. So I'll define a function, let's say det, I'll call it, for determinant. And to find a determinant, I only need a matrix, nothing else. Right? So in my argument will be only one, that will be the matrix. I'll call it A. Now we will need one variable to run over the rows and columns of the matrix A. Now since I'm finding the determinant of the matrix, that A by default will have to be a square matrix. So I need only one variable now to run over the rows and columns of this matrix. Because number of rows and number of columns will be the same, so that will not matter to me now. Okay. Now if n is 1, that means this matrix has only one row and one column. It's a 1 by 1 matrix. So if n is 1, numerical value for n is 1, right? So how do you find the determinant of a 1 by 1 matrix? That will be the one entry only, correct? So if you want me to go to the pad and show how that actually looks, I can show that. So if my matrix A has only one entry, let's say 7, then determinant of A will be that entry only 7, which is nothing but the 0th position of A, right? If it is of order more than 1, then I will have to define a function for it. So if n is 1, okay, if n is 1, then we are going to return A00, because that will be only the determinant of the matrix. So then return, okay, 1 second. So if n is 1, then I'll tell Python to return zeroth entry. That will be in this manner. I'll have to give the position. Okay, 1 second. So 0th entry will directly come as the determinant. Else, now this is called if else condition. If n is 1, it will enter here. Else, I will have to define my function now, the one which I had explained on my writing pad. Else I'll tell Python to return sum of, okay, sum of the entire thing which I had put down on the writing pad. That will be -1 raised to n into A0I into minor, determinant of the minor corresponding to A0I. Now, one thing I need to clarify there is that I will have to take the determinant of this minor here. Huh? So this is actually determinant of this minor, not the minor. Okay. So here also it will be the determinant of this minor. So this function which I am defining now, it's a recursive formula. To find the determinant, actually I need the determinant only, because that's how it goes. That's how you'll have to expand it. Okay, so this will be dealt as sum. Okay, I'll open round brackets, sum of all those entries for all i's going from 0 to n in that case. So this will be sum -1 raised to I will have to take here. Okay, I think there also I have done some slight error there. This will have to be -1 raised to I, not n. Okay, that would be -1 raised to I. So let me work out that now. So this will be -1 raised to I. Okay, how I put this raised to, it's already explained in the earlier videos. Raised to I. Okay, I'll put this in another bracket. So I have -1 raised to I term already done, multiplied by A0I. right? That is the row 0 elements of the matrix. So into A0I, capital A, 0 I, this multiplied by, okay, this multiplied by, okay, I think I missed out one bracket somewhere. Okay, I'll have a look at it later. Multiplied by determinant of minor of, that is my minor function, and minor will have three arguments: A, 0, because I was in the zeroth row, and I. Okay, so I just need to take care of one bracket there. I think I missed one bracket. Give me a minute, I'll just sort it out. Yeah, I think I missed one bracket here. This will be minus 1 raised to I. I don't need a bracket here actually. Okay, minus 1 raised to I into A0I into determinant of the minor of this. So the earlier one I'll close. So I will have to close this one first. Yeah. Okay. So I had opened two here. Two are closed and this one is closed. And now once I close one more, it will close the first one that I had started with. Okay. For I in range of, for I in range of n. So let's check if I have made any error with the bracket. I'll come to know. Okay, so this one, once I close, it should highlight the entire matrix. Okay, so let's check. So at the end of this, I'll tell Python to print the determinant. So print print determinant of E. Okay, so I'll run this one and check whether we are getting the output on. Okay, if there is slight error there with the brackets, we'll try to sort it out. So determinant of this should be 5 minus 8, that should be minus 3. Okay, so let me run this and save it. Oh, yeah. So there's some issue with the brackets there, number of brackets which I've opened. Okay, give me 1 minute, I'll just sort it out. So this one is opened and that's the last one. So this one, minus 1 raised to I plus 1. This one is closed here. So that one will have to close there. So yeah, minus 1 raised to I. So I don't need a space here. Yeah. So minus 1 raised to I, that part is here. A0I into determinant of minor of A0I. So that closes here. So if I get this down, once I close this, it should highlight that I closed all. Yeah. So one bracket was extra. I closed one bracket extra there. I think that was the error. So I'll run it again. Oh, print. Okay, I have a issue with the print there. I think I put extra p. Yeah. So I'll run this now, and that should give -3 as the determinant. Okay. Now this will work for any n cross n matrix, square matrix. No matter how big or how small you take, this is going to work. Okay. So together I have combined minor and determinant program here to get the determinant of the matrix. Okay, I hope you have understood. If there is any doubt, you can ask me in the comments. And yeah, that's it for now. Thank you.